Hello there. Hashing and data mining are hearts of blockchain. Let's understand how you can perform hashing and also how you can mine appropriate hash value based on set difficulty level. We are going to use Python for this demo. Let's begin. First thing, you must import all these libraries. You are going to need this in this project. Next, you are going to write a small function which will return hash value of any message or any data you pass to this function. In my case, the name of the function I am giving is hashing, and it will return the hash value of the message I pass to this function. You are going to use hash_lib module of Python. There are other constructs available of the same module, but for now let us use this module. Return hash_lib, and within hash_lib you are going to use SHA-256. It's better to encode the message in ASCII format and then get the hexadecimal conversion. Very good. Make sure all the brackets are there properly. Awesome, looks good. Very good. Function is ready. Let's test it. Let's test by passing a message to it. I am going to pass a message, hello brother, and let's see the hash 256 value of hello brother. Here you go. It's all hexadecimal numbers. Okay, this was easy. You pass a message to a hashing algorithm and get the hash value. You must be wondering, if this is so easy, then what is this all fuss about data mining and complexity involved and lot of CPU power involved? Okay, let me try to explain you the complexity involved here. When it comes to deriving hash value of a transaction in case of blockchain, you cannot give just any hash value as we have seen in this example. In case of blockchain, the hash value has to follow certain convention. Now you can't change the message. So for the hash value to follow certain convention, you have to combine the message with something called nonce and then derive the hash value of this combination. And you keep changing the nonce till you get the appropriate hash value which fit the rule prescribed by the blockchain. The hash value has to follow that rule. Okay, let's come back to the Python program we were writing. Let's take a small message. Hello brother, how are you? We're going to consider this message as a transaction in blockchain. The real blockchain transaction will be something like a transfer of money and all, but for the demo purpose, let's consider this is the transaction which says hello brother, how are you? We are writing a small Python logic which will combine this message with nonce, which will be a number from anywhere between 1 to 1000, and it will return hash value. The condition on the hash value will be that the first two characters of that hash value should be 11, 1, 1. Okay, let's write this for loop where the nonce value will start and it will loop anywhere between 1 and 1000, and this value will be combined with the message, and hash of that combined value, the nonce plus message, will be derived. The loop will break when it finds the hash starting with 11. What we are checking here is how many times the loop runs before it gets a combined hash value which starts with 11. Very good. The logic is pretty much done. Let's run it. To get the hash value starting with 11, you need to combine hello brother how are you message with nonce 198. That means the for loop has run 198 times before arriving at a hash value of required complexity. Let's increase the complexity. Let's say we need hash value starting with 111. 111. Here you go. That hash value cannot be derived within 1000 run for nonce. Let's increase it to 10,000. Now get it. 7145. That means the for loop ran many more times. 7145 times. Likewise, if you increase the complexity of the hash value with the nonce calculation, will have to run more times to get proper nonce value. This is very simple example where our requirement is limited to first few characters of hash value. What will happen if you put a restriction that the hash value should not exist beyond a number? Bitcoin data miners are mining for hash value of preset complexity. Hence, the logic goes to several computations before arriving at appropriate nonce value. And they have to find this hash value faster than any others to get the reward. And this is why they need a super fast computer. I hope through this small example, now you understand complexity involved in data mining and deriving hash value of a block. This is a very small example, but this can help you understand what lies behind data mining.